Hey there. Welcome back to Properties of Rational Expressions, Part 2. All right, now what I wrote here was kind of what you want to do to simplify these things. You want to factor if you can, and once it's all factored, look for things that you can cancel or simplify. So I've got a little example going here, and I see a little bit of factoring I can do on the bottom. So let's factor that. Well, first of all, let's leave the top alone. And on the bottom, this has no greatest common factor, but it looks to be a difference of squares. So let's go and write that out in its factored form. X times x. And to make 25, I need 5 times 5. And because it's a difference of squares, one will be plus and one will be minus. So it's all factored now, and I tend to like to put brackets around stuff like this, just to kind of makes it easier on my eyes. I can look at it and say, hey, this little bundle here and this bundle here, I can just cancel. See, I think of it as a kind of I bundled it together. So what's my actual answer? Well, what's on the top is actually a 1. Yes, there is a 1 up there. And on the bottom, I have x minus 5. All right, well, there's my answer, my simplified rational expression. But wait, what of the restrictions? Okay. Now, a lot of students will rush in there and they'll say, yes, positive 5, that's bad. And they're right. Yeah, it is bad. But you know what? Negative 5 was bad once. And so, once you're bad, you're always bad. Yeah, even if you get canceled away in these things, you've been your good name has been smeared. That's how you got to think of this. So, really what we're talking about is before you did all the canceling, what were our restrictions on the original? And that's why it's plus and minus 5 as far as restrictions. Okay, so let's clear the screen and do another fun-filled example. All right, in this example, we have 2x squared minus 8. Okay. All over x squared plus x minus 6. Okay, so away we go. We're going to factor the top and the bottom. First thing I see is a common factor. So I'm going to take out that 2 as a common factor. So that leaves me with x squared minus 4 on the top. And on the bottom, there's no common factor, but this trinomial, we should be able to break that down with an x times an x. So I need two numbers that make negative 6 when I multiply that add up to positive 1. I'm thinking I can work something with a 3 and a 2. So I'm thinking positive 3 and negative 2. Okay. Well, on the top, I've got some more factoring I can do, and that is this difference of squares. So let's factor out that difference of squares on the top. Okay. So x plus 3 and x minus 2 on the bottom. Okay, now our difference of squares would be x and x, 2 and a 2, and a plus and a minus. Look at this bundle on the top with this bundle on the bottom. Those cancel. So here's what's left, and there's nothing I can do to simplify it any further. And generally speaking, we leave it factored. There's little gained here if I were to expand out the brackets. So I would just write it like this. You don't need the brackets on the bottom anymore. We know this is the stuff that's on the bottom. The only other thing I'm going to throw in here is restrictions on x. X cannot be negative 3. Clearly that's a problem. And positive 2, even though it got canceled, it was a problem once. Okay, so that's all we have as far as these examples. So I'm going to stop there. And we're going to come back with the next lesson. Lots of fun.